So the three states that matter can exist in are solid, liquid, and gas. So a solid is a substance that's going to have a definite shape and a definite volume. A liquid will have a definite volume, but it assumes the shape of its container. And a gas is a substance that neither has definite volume or definite shape. So those are our three different states, and every different element or compound on the earth can take these different forms if they are under the right conditions. So water is a really good example because it exists naturally on the earth in all three different states. And that's because temperature plays a key role in converting a substance from a solid to a liquid or to a gas. So we know that the freezing point of water is going to be at 0 degrees Celsius or 32 degrees Fahrenheit, and that's when water moves from a liquid into the solid state. So that would be its phase transition between these two physical states. We also know that water will boil at 100 degrees Celsius, and this is when you're converting liquid into the gaseous form. But we can also do that for all other compounds. They all will have their specific boiling point, and they all will have their specific freezing point. And so we'll see some examples of this. So this is just showing our three different states that we can have our compound in. The solid, again, has definite shape and definite volume. The liquid has a definite volume, but the shape is going to conform to the container, in this case, this big square. So a gas neither has defined shape or volume, and so it's going to take on the volume and the shape of the container. So by adding heat or changing the temperature, you can change the physical state of the substance. And so we used water as a very good example of that. When you reach the freezing point of water, you can get it to form its solid state. When you reach the boiling point of water, you can get it to go into the gaseous state. So again, this is a physical change because the chemistry of the molecule is staying the same. It's all H2O, or water. Okay, so there's one more concept that I want to cover about our physical states, and that is this concept that temperature can cause changes in the physical states. So if we have a temperature scale here that we're setting up down here, we can see as we increase temperature that for any substance, we're going to use water as our example again, that along this temperature scale we can predict where something is going to be in a different physical state. So if we start with our water, we can see at 0 degrees Celsius that on this side of the scale, our water is going to exist as a solid. So on this side, the water will be a solid. So in between 0 degrees and 100 degrees Celsius, our water is going to exist in the liquid phase. And above 100 degrees Celsius, our water is going to exist in the gaseous phase, or gas phase. So at these various transitions, we can call these transitions different changes. If we're going from a solid to a liquid, this would be the melting point. So this is from solid to a liquid. So if we were going back the other way, if we were going from a liquid back to the solid, what would we call this? We would call this the freezing point, right? So this could also be the freezing point. And so this would be going from the liquid back into the solid state. So we can also have these changes going then from the liquid to the gaseous phase. If we're going from the liquid to the gas, so we're going in this direction, what would we call this? This would be the boiling point. So that's the point where the liquid is going to boil and turn into the vapor or the gaseous phase. How about if we have the gas going back into the liquid? What would that be called? Does anybody know that one? This would be called condensation point. On the news with the weather, you might hear this as the dew point. That's where you're going to get dew left on the grass and the different vegetation, because the gas is going to be being converted back into the liquid at the condensation point. We do have some phase changes that can go from solid directly to the gaseous state. So you can go from this guy all the way to the gaseous phase, and you can skip the liquid phase. So if you have a solid going to a gas, so if you've got solid going directly to the gas phase, this process is called sublimation. And so the liquid phase is skipped. Okay, so instead of melting or boiling, we would have sublimation going on if we go directly from a solid to a gas. If we go directly from a gas back to the solid state, this would be called precipitation. So if we have snow falling from the sky, for example, this is going to be an example where we're going straight from the gaseous form of water back into the solid form. So that would be an example of precipitation. For any substance then, we can write out this temperature scale and we can determine where we have the solid, the liquid, and the gaseous phase. So you might try a couple of problems where they give you, say, the melting point and the boiling point of a substance. You should be able to put them down on this scale, and you should be able to fill in where there's a solid, a liquid, or the gaseous phase of that substance. So water is very unique because all of these different forms exist naturally on the earth, and so it's very easy for you to think about this substance in this way. So, but for all the different compounds, there is a specific temperature scale that we can take a look at. And so one of those, let's just use another example. So if we use another example, let's use sodium chloride. So sodium chloride is normal table salt that you would sprinkle on your French fries. And we're going to see that sodium chloride has different properties than water. It is actually a substance that's held together very tightly. We will see the melting point for sodium chloride is 801 degrees Celsius. So that's very hot. If our scale goes all the way down here to 0, and we say we have 100 degrees here, this is where water is going to exist in the liquid phase. It would be gaseous above here, it would be solid below here. So the melting point for sodium chloride is way up at 801 degrees. Where is the boiling point? The boiling point is way up here even further at 1413 degrees Celsius. So very hot. So if we have water on the lower scale, so if we write water down here, water is going to be a solid down here. In between here and here, it's going to be the liquid. And then above here, it's going to be in the gaseous phase. So we would have, for water, solid, liquid, and gas. If we were to write the same type of scale for sodium chloride on the top, this is going to be the melting point of sodium chloride, 801 degrees. So below the melting point, it's going to exist in the solid state. So solid sodium chloride. In between here and the boiling point, so the melting point to the boiling point, we are going to see the liquid form of sodium chloride. And then above the boiling point, we would see the gaseous form of sodium chloride. So for any substance, we can write out the different phases that these compounds should exist in based on the temperature scale. We'll also see that another feature can also alter the physical state of compounds. So we said that temperature can affect can affect the phase that a substance is going to exist in. Another thing that can also affect the phase is pressure. So if you put enough pressure on a substance, it's going to drive it in this direction on the scale. So if you increase pressure, you're going to push that substance towards the previous phase state. So even if we have very high temperatures and we have sodium chloride existing in the gaseous phase, if we put enough pressure on it, we can squeeze those molecules so close together that they'll form the liquid state of the sodium chloride. So the temperature scale is going to be affected as well by the pressure that the compound is under. So temperature and pressure are two different features that can affect the state that a compound is existing in.